Hello, my name is Pohlmann and I'm a postdoctoral researcher working on a VR project at the University of Glasgow, and I use virtual reality headsets to try and mitigate motion sickness that is experienced in moving vehicles. The VR project aims to improve travel in all types of transport such as cars, trains, buses or planes by allowing for the use of virtual and augmented reality. The project is divided into three sections. One explores how we can use VR and AR headsets in confined spaces, such as in our seats on a bus or plane. Another part of the group explores the social acceptability of using XR headsets in public transport, and Gang and I are part of our group researching motion sickness. Gang looks into using neurostimulation to mitigate motion sickness, and if you want to hear more about his work, you can watch his video on our website. And I focus on using multiple sensory cues to try and reduce motion sickness. So why use XR headsets while traveling? Usually when traveling, we are restricted to using very small displays such as our phones, tablets or laptops, but VR and AR allows us to overcome these physical restrictions. While working, you could have multiple displays around you, or you could watch a movie on a cinema-like screen or play a 3D immersive game. But as we all know, traveling in automated vehicles by performing such non-driving related tasks can lead to motion sickness, which can have negative effects on game enjoyment as well as cognitive performance. Before joining the VR project, my research mainly focused on cyber sickness, so motion sickness experienced when wearing virtual reality headsets. This kind of motion sickness, similar to motion sickness experienced in cars, is caused by the conflict between the visual and vestibular system. In the case of VR headsets, users experience visual-induced self-motion, also called vection, while they are physically stationary, and this can result in discomfort and motion sickness. My PhD research focused particularly on how motion direction, lateral motion versus motion depth, and eccentricity, so central or peripheral presentation of motion, can affect cyber sickness. I was also interested in the relationship between vection and cyber sickness because ideally we would want an experience that elicits vection, an experience of self-motion through the virtual environment without causing cyber sickness. We found that generally optic flow presented in the periphery and moving in depth elicited the strongest sensation of vection and is the best for a sensation of self-motion through the virtual environment. This is interesting for us as it means that when users are wearing VR headsets that we can present a virtual screen in the center of the visual field, allowing them to watch a movie or work while we can present visual motion stimuli matching the cam motion in the periphery. I'm also interested in exploring how performing a cognitive task can affect motion sickness and what negative effects motion sickness can have on users' task performance. This is important as we expect many people to use VR to work while commuting to and from their workplace. So we need to find out how we can make this most enjoyable and productive for them. On the previous slide in the center of the visual field, you should have seen these little monsters appearing one after another. They are representing a rapid serial representation task, a cognitive task. 10 different monsters are presented one after another, and participants have to react to one or two of them by pressing a button on their controller. This task can induce different levels of cognitive demand, depending on how many of these little monsters are targets, or depending on how fast they are presented. In this study, you can see that participants had to perform the same task while being seated on a virtual roller coaster. This roller coaster was expected to induce a strong sensation of vection and cause cyber sickness. In both studies, we found that vection and cyber sickness decreased when participants performed the task, and that participants performed worse on the task when they experienced cyber sickness. This just shows how important it is for us to find a way to eliminate motion sickness so we can use our commute to work productively without our performance being affected by motion sickness, and it also demonstrates an alternative motion sickness mitigation strategy that is independent of any sensory inputs. My research also focuses on investigating physiological and particular neurological measures of both vection and motion sickness. For this, I have used both EEG and prefrontal functional neural infrared spectroscopy. These neurological sensors could be integrated into modern headsets in the future, and whenever they are detecting cyber sickness in the user, a motion sickness mitigation strategy could be initiated. This could, for example, be changing the visual content that's presented to the user or inducing neurostimulation. Since joining the HARO, I went from focusing on solely visually induced motion sickness to motion sickness that is induced by physical motion. I'm working with two different setups at the moment. I've been running a few lab studies using the rotating chair that you can see in this video here, and I'm using a car while we're driving around Glasgow. In my lab studies, people perform a reading task in VR while I manipulate what I present to them visually and auditory. In our first experiment on the chair, we investigated the effects of visual motion that matched the rotation of the chair, presented either in the full field of view, as seen to the left here, or only in the periphery, as seen to the right. This was done to find out whether peripheral presentation might be enough to reduce motion sickness without being too distracting from a primary reading task that is displayed in the center of the visual field. The rotations of the chair were based on an urban city drive through Glasgow city centre and lasted for 15 minutes. The study consisted of 4 conditions: a baseline condition in which the chair was stationary, a baseline condition in which the chair was rotating but no visual motion was presented. This condition was expected to be causing most motion sickness, as well as the full field of view condition and the partial field of view condition. The 2 baseline conditions were found to be significantly different in motion sickness, with the one with chair rotation causing most motion sickness, which suggests that the chair is able to induce some sort of motion sickness. However, the rotations that we chose for the studies were not very sickness-inducing in general, with very low sickness scores in most participants, which is why we believe that we didn't find any significant effects of the visual motion conditions in this study here. We did, however, find that motion sickness scores in the peripheral and full field of view condition were rather similar, and the peripheral condition was perceived as less distracting, which suggests that we can use these visual motion cues in the background behind a primary display that can either be used to work or, for example, to watch a movie in the car. Because participants in our last study did only experience mild motion sickness symptoms, we enhanced the rotation profile of the chair for our next study to induce a stronger sensation of motion sickness. In this experiment, we did not only display visual motion stimuli that matched the physical rotation of the chair, but also introduced auditory stimuli that gave information about the user's movements. Auditory motion cues have been shown to be able to elicit a sensation of action and have been shown to enhance visually induced sensation of action when added to it. So we were interested whether the addition of such cues can also reduce motion sickness. As you can see, we also changed the virtual environment to be more visually engaging with various landmarks such as parks, a cinema, and cars. With our auditory sounds being matched to some of those landmarks in the virtual environments, the sounds we chose were church bells, bird sounds that were located in the park, and construction sounds. While immersed in the virtual environments, our participants were performing a reading task similar to the one from the first experiment. And I don't want to talk too much about the results of this study because we're just writing it up and we're hoping to submit it to a conference quite soon. As I mentioned before, we're not only running our experiments in the lab, but we're also testing participants in our project car on the roads in Glasgow. We have a sensor board that gets information from the car OBD, IMU, and GPS, and we combine this with our Unity motion platform that allows us to take the orientation, velocity, profile, and location of the car and manipulate this online or play it back within Unity later on in the lab to do some testing. If you're interested in how this platform works, we have a paper coming out in WIS this year that explains all of this in greater detail, and the Unity side of our platform will also be available for everyone to use later on this year. In the videos on the screen here, you can see a spaceship traveling through space using the car velocity and orientation representing a gamified use of the platform, as well as a productivity example with the user viewing multiple screens in front of them while the car motion and orientation is presented in the background. This example additionally uses GPS data and a map plugin to populate the virtual environments with buildings that are similar in size and shapes to the one we're driving past in the real world. I'm currently also working on a study in which we're using the motion platform to manipulate the visual motion perceived by our participants while they're seated in the car and they're again performing a reading task. I'm doing this reading task again because I'm mainly focused on the productivity side on VR usage in cars at the moment, and hopefully we're ready to run this study when I'm coming back from Auto-UI. In future, Gang and I are hoping to combine both of our mitigation strategies in the car, using both neurostimulation and sensory motion inputs to find the most efficient combination to mitigate motion sickness and hopefully eliminate motion sickness completely in the future. Thank you for listening, and I hope to see you soon in Seoul in Korea or online for our workshop.